Okay, hi everybody, I'm Georg. Sperl by now, had a recent name change as a married. So if you did see the slides or had your schedule printed earlier, you had my old name, so I still have it on the slides. And I'm team lead of the infrastructure and services team at Dynatrace. And what we are responsible for is the infrastructure and services side of the CI. So it's actually a build environment, continuous integration, and we are running tests there. So maybe a little bit different use case than most other guys have here. And I will just try to give a short overview how we use OpenNebula in the CI and how it actually helped us transform the CI. So first short thing, what is Dynatrace? We are basically a software company. We are building an agent-based performance monitoring platform. And we have a cloud-based SaaS offer, and you can as well run that on-prem. I will not go into a lot of details. Just the one thing, we are not just a data sink. We try to give the user some useful information based on all the monitoring data. If you want to give it a try, go to the website, run a free trial, and see if it can help you. Okay, so short overview over the Dynatrace CI. We are currently having 450 developers working on the product code and actually always growing. We build and test basically every commit. So every commit, every merge triggers a pipeline run to actually build the whole product. So there is a lot of going on in the environment. And we as well have to deploy multiple times a day to a bigger demo environment where we actually have some real, some load against the system, where we have load drivers and all the different technologies covered so that the developers actually see, okay, my feature not just performs in my simple one instance environment, but as well in like an environment with hundreds of hosts. And of course, software company, we need to support multiple release branches. We use different build systems. We have our code in Git. We use Artifactory for artifacts and everything that you would expect in a CI environment. Our core languages in the product is Java on the server side, and on the agent side, there's always the core part that's in C++. And then doing all the native stuff. And the special point about our CI is maybe that we really need to cover a lot of different architectures. So we are running basically, we have KVM, we have VMware, we have Solaris Zones, we have PowerVC, we even run a mainframe, we have Kubernetes and OpenShift as well. And the main reason for all that diversity is that we need to support multiple platforms. We built the agent for multiple platforms, for multiple technologies, and we need to do that on a bunch of architectures as well. So x86 is our main driver. It's our basic standard CI environment. But beyond that, we as well have Spark, we have PowerPC, we have S390. And then the operating system side, most of it is Linux, luckily, but not just one distribution. It's basically everything that any of our customers uses, and we need to support old versions as well. So we have quite a lot of images in different versions with different distributions. Alone on the Linux side, of course, all versions of Windows that are in use. We have Solaris, we have AX, and we as well have COS, so mainframe architecture. Okay, so let's dive in. How do we use OpenNebula in the Dynatrace CI? Let's start with a few use cases. We actually started using OpenNebula as a unified way to run our KVMs. I guess a lot of you came the same way. You start using KVM, and then you just need to maintain that. And OpenNebula offers is great in that regards. It provides us with an easy way to just ramp up new instances for the CI or for services that are long running. And we can as well offer self-service to our developers, so everybody can just go to OpenNebula, click an instance, work with it, throw it away if you don't need it anymore. And that's our main driver really in the CI. That's the EC1 API that we use for dynamic instance creation. And that's where I really want to focus on because we use it by now basically everywhere. We run our standard build nodes from immutable images. We ramp them up via EC2. We have our installer tests that provision all kinds of operating systems, run the installer against it, and see if everything works. They are just started up, create the instance, run the tests, throw away. And we as well have a bunch of instances with a specific software stack on them that you don't need to run the full day. It's basically, okay, there's an integration test against this or that stuff that you don't need to have in every build. And then just start up the instance and don't waste the resources on a VM that's not actually used. And that actually brings me to our journey from the static to the dynamic CI that we did, mostly with OpenNebula. And first, I want to go into our three main objectives in there. And that's, yeah, we need to build every merge. That's simply a fact. Our feedback to the developers needs to be fast, so we can't afford to have, a developer checks in something, runs the merge, and 2 hours later he gets the response, he broke the build. That doesn't work, not at 450 developers and growing. 15 minutes is our timeline, we can't go beyond that. And yeah, resources are not endless. There might be people who have endless resources, we don't. So we first tried, in our static way, the first approach was basically we have one resource set and the builds take whatever is there and run with that. Works fine until you scale to some point where it just doesn't work anymore. So then we started splitting up resources, like have special resources for trunk, special resources for sprint. Yeah, it's hard to plan. It's you always need to reevaluate, and you run into situations there where you have no resources on one part and and all the resources are idling on the other side. So we went basically to go full dynamic, use the EC2 API. And we wanted to go use the resources efficiently, keep feedback times low, no compromise on building, and we wanted to do cloud bursting as well if we want to, and perfect, OpenNebula does all of that. So creating instances with OpenNebula, we have a Gradle plugin, for example, from the build where we can ramp up instances just out of the build, give me this or that. We have in the build servers, the pipeline stages know how many instances they will need. The pipeline stage starts, it spawns up the instances it needs and throws them away if they are no longer needed. And this way we can easily scale, and even if we have a bug fix, merge back to multiple sprints, we can just scale up in that way. Yeah, and all the base instances, same way, just spawn them up via the EC1 environment API. You don't need to do configuration management because it's all immutable images, and you can easily replace your images if you rebuild them because you get new instances all the time anyway. There is no replacement, basically. Okay, short about image and host management. We build our images with Packer and Puppet. Basically, if you run a CI, you don't want manual image builds. You can't maintain that really. So Packer offers us a nice and easy way to build the same image for different hypervisors, VMware, KVM, or AWS even. And in there we run Puppet because we used Puppet before. So we have all our code in Puppet already. We needed to adjust it a bit to have it in this one separated run. while in the legacy CI you have it constantly running. But we could use all the configuration as we use Hiera, and we can use that in both places. And it allows us to easily build different flavors that build on each other. Like we have a base image, then you have the image with Docker and so on. And that's quite easy to do in that way. We needed a little tool to maintain that on OpenNebula for like you upload a new image. You need to find the templates that are affected by that image. And we can do that quite easily because we have a standard naming scheme in our images. So we can categorize by this, identify the templates, and just replace them. Yeah, and we have some reminders for the developers to throw away their instances. Unfortunately, it's not very generic. It's like very specific to our use case. But if somebody has questions, please come to me after the talk. I will try to help out. And the last thing, a bit about our KVM hosts. We are running our KVM hosts on Arch Linux, which is nice for like the new kernel, latest packages, and so on. But it's hard to maintain. You have problems with like rolling back, downgrading, and so on. So that's not that easy to do. So we went into actually building PXE images that we start up via PXE, boot up create a temp.fs in memory, extract the image, start that up, have a bit of configuration in the SD card. Boots fast, is reliable. Updating the host is just rebooting, and you have the disks that you have in the host free for store pool, Ceph, or as a data store. And you can do whatever you want with that, and it's really easy to maintain after going through the first hurdle to build that. Yeah, okay. I think the timing would be...
Very much.